Okay, so now to configure a router, and then like I explained the other time, and I clear myself that routers are many in the market, but Cisco routers and switches dominated more than 80% of the market share. That's why it is tenable for somebody who is coming in to networking and security environment to learn something that's predominantly usable or that is like household name in the industry, which is Cisco. Even some people think Cisco is the networking because 10 in every, let's say 9 in every 10 organizations use Cisco routers and switches, as case may be. So learning how to configure it is not a waste of time. So now, the initial configuration started this way. After the enable command, you put the config T or configure terminal, and then you specify your interface and you put the IP address. So this is the command. We have put IP address 192.168.5.1, and they put the subnet mask. Does anybody have confusion or doubt about subnet mask?
I still do.
Okay. Subnet mask, as case may be, like you having your house now. Your house has a number. But if I just type, if I'm sending a message to your house now, I write your name and I put only your number. Maybe you are living in number 74 or Mosheton Moyo Street.
Okay.
So now I send it to you, but I did not put the area code. Do you know that there may be somebody somewhere in the world behind your name, living the same address you are living, the same Mosheton address somewhere else, which is possible. So, but when you put the zip code, it will differentiate Mr. A from Mr. B.
Okay.
So now on networking, subnet mask is the one that differentiates different network from one another.
Okay.
And another question is, this subnet mask, does it have to be all this every time, or it can be changed? Because this 25.255.255.255.
You shouldn't have that question.
I'm just asking, because
Mr.
I'm getting confused.
Dayoka has that question because we started together.
I know,
when we talk about class now. A. You said?
I said I'm just getting it confused now. That's what I asked that question.
Okay. Don't get confused. See, we are using this one. The most commonly used subnet mask is /24 because it has smaller IP address or smaller usable IP address compared to class A and class B. This one is class C. I'm giving room or analysis of how we've done subnetting before. So now maybe we still need to visit it because I know it's a little bit confusing, but let's just, as time goes by, it will rub you now see how it works. But just know that IP address must go with subnet mask.
That's it.
That's it. Because now, if I don't put the subnet mask, the computer will not be able to know where to forward this traffic to. And then another question you may love to ask is, okay, if it is this zip code, but why is this zip code that is commonly used by all of them? That is, we have /24 here, we have /24 here, we have /24 here. We have 24 here. Another, the answer to that is, even in our environment, in the streets, I know some people on this platform, we are living the same zip code. But are we living on this in the same street? The answer is no. If you send something to 192.168.1, this is a marine. .1. You are sending something to me now. I'm 192.168.1 or .4. That's my own house address, for example. That .1 has let you know that .1, maybe the name of my street is just like maybe Veteran Memorial Highway. That one will represent on that zip code. Another zip code, which is .2, it cannot be Veteran Memorial Highway again. It can be like maybe on Backhead or maybe Power Drive. Or I'm just giving small analysis of those .1, .2, .3. Let us know that this subnet mask or this particular IP belong to particular subnet. They are not, you see, if you assign IP 192.168.1 on one PC, we assign 192.168.2 on another PC. Both of them can never communicate because the two PCs with systems, they will see each other as communicating from different zones. Okay, we have tried before. Maybe we still need to try today again. So, because before this thing become convoluted, we need to get the picture clear. So is that clear, or I need to say more about it?
We can continue.
Okay, but do you get the logic?
Yes.
Okay. On this packet tracer, if you want to send a packet to one device, if you don't want to type ping, you can come here. Let me see. Can you see my screen?
Yes.
Okay, let me show you where you can just play with it. You see this thing? Can you see those?
Yes.
Okay, you can pick any one of them. When you pick, okay, I'll do it now. Okay, I'm sending a packet from PC1 to PC4 now. And then look at here, there's a place called written successful in the packet tracer below. Okay, now, if I pick a packet here, let's say I pick a packet now. Okay, okay, I'll go to, it's in real time now, go to simulation. So if you look at it, they are simulating. So it's sending packets from one position, from one source to another. But it can never be successful because there's nothing, they don't know each other, they don't know anything. You see fail. I don't know if you can say it.
Yes.
This is the real-time analysis. It will fail because there's no route, there's no communication going on between them. And this is what goes on behind the scene that many users don't know, apart from network engineers and the network security engineers. As you are communicating to me, you are hearing my voice. This is what is going on between us. Between our laptops, between our devices. It's not a magic, it is combination of algorithms and the lighting, it's a speed of light. That's why when you look at them, when you look at the speed, it is milliseconds. So if you want to do this kind of thing on your laptop, on your own lab, you just click on simulation.
And everything will be showing like that.
Yes.
Okay. Okay.
So now I've come back to my read time.
Fine,
We have read time, we have simulation. So when I configure all this route finish, I will do the same thing. You'll see it yourself. You'll see it will be doing successful. But now you see that it's saying failure, fail, because, and then it will, this packet tracer will identify the protocol we are using, the kind of packet it's sending. If you look at here, it's showing that it's sending ISP, ICMP. That is ping. So let's move on. It will eventually rub off. It will be a kind of rub off effect once we don't stop. And then why we don't, what the only key to achieve it is through practice. It's not about memorizing it. It cannot help. Okay. And then having this lab is key. Play around with it. If you don't understand, there's a lot of materials on Google. There's a lot of materials on internet. Even YouTube is like university.
Yes.
So we just need to know what to consume, and then we go straight to it. So now, don't forget, we have not finished configuring this router. We are still on this one. So I'll go back to it.
So the interface G000 has been, and G001 has been configured, right?
Yes.
So we are working
now I've
on
just click enter.
G010. Okay. Okay.
Okay, I click enter. It said the IP address is wrong. It's an invalid input. Right. Okay, let me do it again. It's showing that IP, if there's problem there, IP address. Okay, let me exit from here. Okay, interface G0/1/1/0. Enter, and then I put my, okay, it's saying it's rejecting the IP. Why? It's rejecting the IP. Okay, no short IP add. It is not recognized. Okay. What's going on that interface? Okay, let me do something here. G0/1.
Because I don't think it's on this interface. That 010 is not here.
Okay, it's
Okay,
telling us
that's
that
it.
it's on VLAN 1. Okay, let me see this one. Okay, this one is configurable /2. Let me delete that one then. Mm. Okay. Maybe I will delete this one. That particular router may not allow
Yes.
that for now. Let me delete that interface. I will bring another router later. Okay. Let's push this one aside. Okay. Now we have configured the two interfaces that is attached to and then if you are working on a router and then every command you send or you put in a router, you need to save it. Otherwise, if you boot up, all those commands will go blank.
So how do we save it?
So on your Cisco router, you do
Right.
WR.
Right,
WR
right.
means write.
Okay.
You write it on the memory and you click enter. So when you do enter, it will show this one, building configuration.
Yes.
So now write that WR is the complete is right. It's right. It's like you are writing it to the memory. So that's a very simple command. He said
you can write, you can as well do write memory too, the same thing, right?
you can do write to memory if you want, but
Okay.
me, I don't like go. You see, all this route you are following is not our destination. Our
Okay.
destination is firewall.
Okay.
So we just need to know basic things to get it going. If you want to go deep dive on networking, you can do it on your own.
Okay.
Yep. If you want to go that route, that is why it's good to tell yourself, okay, this is where I want to go.
Okay.
Because tomorrow you may find yourself environment where they have Aruba switch, they have Aruba router, they have HP router. You need to learn those commands too.
Okay.
Because all this command will not work on any other device apart from Cisco devices.
Cisco device. Okay.
So now we have completed this interface, this router. For now, what we have not done there is we don't have a route defined. So now to show that, we can do show IP route. Now, if you look at my screen where I highlight, so let me use this stuff to do some write up. If you look at here, you see C, right?
Yes.
So now look at here, you see C here now too. That
Yes.
is C, that is connected.
Yes.
It shows that it is directly connected to this interface. On this point too, it shows that it's directly connected to this interface, right?
Yes.
It did not show S. When we do static route, it will show us S. When we do OSPF, it will show us O. When we do BGP, it will show B. Like that, like that, like that. So now when you run this command, show IP route, let me clear this back. Quickly, you'll be able to know, oh, do I have route to particular interface or just connected interfaces? This is just directly connected interfaces. If you are going from DPC1 to Texas, you can go because your router can identify that it has a neighbor connecting with on this interface. right? But if if you're moving out of this zone, like out of this 192.168.192.168.2.0, you are going to .3. You need a route. The traffic will not go there because this particular router doesn't know anything. It has zero knowledge about .3. He has zero knowledge about .4. So we need to specifically assign static route to it before he can be able to communicate with all devices on that subnet. Is that clear?
Can you explain again, please?
Okay. Now, this is how it works. It is not difficult, but it's a little bit logic.
It is.
Yes, it is not difficult. Just a little bit logic. Look at it. Look at our route. The
Yes.
PC is coming from here.
Yes.
When it reaches here, it knows, this route knows about this interface. This our PC1 is connected to this subnet. It knows about this interface.
Yes.
But this router, because now it's like people that are raising this thing out, they thought about a kind of chain of man that form a wall. So now if you give me something, maybe we are doing batting. If you give me something, I give it to the next person. Right?
Okay.
If I give it to the next person, I expect that the next person to give it to the next person.
Another person, yes.
So we'll be changing the bat or the batting to the end, to the destination. Now, you can't give it to me if me and you are not close or we are not connected.
Okay.
So now the same thing applies on these logical connections. This router, the PC is having information of this router. Now it's going to here. It's coming to this place, for example. But this router he has given to doesn't know much about this subnet. Though this router knows everything about here, but it has zero knowledge about here. It has zero knowledge about here. So we need to assign a static route to this one. So we will propagate this subnet to this router, this subnet to this router. The same thing to this router. This router knows about .3, .2, but it doesn't know about .1 and .4. We tell the router about .1 and .4. The same thing applies here on this router. This router knows about .4 and .3, but it doesn't know anything about .2 and .1. They just need to exchange all their connected informations. This is the advantage of dynamic route over static route. It is boring for administrators to go to all the routers to assign IP and propagate all the connected subnets. Is that clear?
Yes.
So now let's move on. And then we are now 1:30. Let's quickly, for me to do it blue, blue, blah, 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 blue. It's not difficult. It's not difficult for me. I just want a situation whereby we know why we are doing certain things. It is very easy for me. What I will need to do is just to create a notepad, which now that's what we do on other routers. We create a notepad, we put our configuration there and we paste it. Because the way we do this router 1, that's the same way we do router 2, router 3. It's a repetition pattern. So instead of all to do that, so we just need to quickly let's do copy and paste. Let me do copy and paste here. Let it come. You can't say your dad is here. Yeah. Good. So Mark, let us here. So now, let me share this my screen. I'm sorry if you are hearing some noise in background. They give me some outside jobs. Okay, can you see my notepad?
You've taken it off. Okay, I can see it now. Okay, it's
Why
gone.
is it running away? Okay. I'm clicking out of the notepad. Okay, now if you look at my notepad, this is OSPL. No, I will not use do this one now. Let me go here. Now, what I need to do just to identify where I'm going to. The same enable config T. This is a description, the host name. If you, I don't want to do all that now. This is a description. I can just, let's do simple stuff right. So now, look at here, I will copy it and I will paste it here because I'm working on two interfaces. Now, the router on Texas, let me do something here so that it will be clear. Texas router. Texas router. See, this is Texas router. And then we copy this one and paste it there after we make sure the IP is correct. So on the Texas router, our IP will be, let's start with the interface first. The interface is G0/0/0, right?
Yes.
And then the IP address is what? 192.192.2.2. Because don't forget, we have assigned .1 to this one. This one will be, this is .1, this one is .2, and then this one will be, we can put .2 here too. This one can be .1, this one can be .1. And then here, this one is .1 already. This is our PC, we can put .5, .5, okay, .5, .10. I'll just use .15, .20. If you have a question on assigning of the IP, let me know. Because in /24, we have 254 usable IPs. So you can assign as within that range to a particular set of devices. I hope that place is clear, right?
Yes.
Yes.
Okay. So now, I've labeled all this one. Even sometimes the labeling makes it easier. So now, on this our router, we go to the command line. So first of all, let's do enable, and then we'll do show IP interface brief. Okay, it seems I've even assigned IP on this one before, but I will negate it. If you want to negate it, do config E, and then you write interface G 0/0/0, you click enter, you now do no IP address. You can remove it. The same thing on /1, I do no IP. So I do end. So once I do end, I now do the same command I run before, show IP interface brief. I click enter. Look at it, it shows that there's no IP here. Clear? And it was having IP before, but when I run this command no IP, it's automatically erase it. So let's work on our notepad. So we said we're going to do .2 on the gigabytes 0/0/0, and then the other interface, which is 0/0/1, will be what? Will be 192.3.2. And then now what you need to do is just copy it from the enable. Copy everything, copy. And then go to your router, exit here because I put enable. So just click here, hit paste. Once I run the paste, it populates it, and then everything it looks promising. So now we do end. Then don't forget to run your write command. Save the configuration. So we have done with that interface. The same thing here too on this router. We go to the router. Okay, enable config P. I want to erase the interface. I don't know, maybe they have IP already. But let me erase it quickly. Interface G0/0/0. Click enter. No IP address. The same thing on G1. No IP. I don't know, maybe there's IP there already. You do end and then exit. So we'll go back to our notepad. So on the notepad, I copy everything here. I paste it. I put this one, what will be, it now be South Carolina SC router. So on the South Carolina, they are now this, they are only have it has only what? It has 3.1 and then 4.1, right? 4.1 space. So here we copy it to copy, and then we go to the router, click enter, and you paste it. So you do end and then right. So now at this point, what we have achieved in doing is we have achieved in assigning IP to all the interfaces, but there's no route. For us to confirm that, go to simulation, click on simulation, and then it will click on this play sign. So once you click on this play sign, they will be sending packets between each other, but it will not fly. It will be showing fail, 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 fail. So can you see the fail? So now let's do static route now. So when we do the static route finish, we send the packet across the board. Once it fly, we can call it a day, and then we do dynamic routing next time with this same topology. And then I will urge every one of us, take the screenshot, do your own assign IP address, do the what's it called, static route, test it Once it can work, we are moving. We are moving because even on the firewall, we have routes. That's where we talk about virtual routers. So anything you learn this platform or anywhere you find it, it's not a waste. It will become accumulated. Because now, if somebody is asking you on an interview, say, how can you send a packet from one device to another device? It will be on your brain. It will just be on your head. So, okay, there must be a route, and then the interface must be assigned with a specific IP. So when you are talking, it will be flowing as if spontaneously everything will just be coming out. So, but it starts like this. So now, if you look at this failing, so I'll stop the simulation. We'll go to read time again. Okay. Let's start from Georgia router first. How can we create a route? Now, mind you, what we are creating now, static route. Will show us how to do static route, how to do default route, how to do OSPF, EIGRP, and BGP. But the one we are doing now is called static route. So how can we do that? We go to our device, we click enable, and then we go to, we type config key, that is configure terminal, we enter. So now do a static route. This is the command. Do IP route. So I'll stop here. I'll pause here a little bit just to see it. The command is IP route. So when you put the IP here, we now specify your subnet you are routing to. So now, if you look at it, logically, we don't need a route for all our connected subnets. We don't need a route to the one we don't know. So now we need a route to 192.168.0.255.255.0. So we are telling our router a static route to this subnet. And then now we need a gateway. If we are going here, where are we following to this place? We need to follow our router 2, our Texas router. It will be our gateway. So we need to assign 192.168. Okay, before I do that, let's do something like it. Sometimes if you don't understand what needs to be, at this point, you can run this, you can just check, put question mark behind your command. It will show you other things you need to do. You see, it's specified that forward a router address, Ethernet, fast Ethernet, Giga Ethernet, and what? Low back, they are all here. But what we need here is what? We need
forwarding
a gateway, which is 192.168.3. What do we give that guy? What do we give that guy? .2.2, right?
okay.
What we are telling this router is this. We tell this router that if you are going this subnet, which is 192.168.3.0, you follow through this guy. So now it knows where to forward the packet to. If anything, if I'm sending a packet from PC1 to this subnet, the router is intelligent to send the packet to 2.2 so that 2.2 can forward this traffic or this packet to the destination. Right? Okay. The same thing applies to the second command about the other subnet, which is .4. We run the same command. Instead of repeat the command, you can just put your arrow key up to populate it, and you change the IP from 3 to 4. Send enter. At this point, we have done static routes. Any confusion or doubt? Okay, but before we do it like 2 times again, it will come up. So now at this point, if you want to do your write to command, you can do route here. It's the same thing, because at this mode, you need to run DU before this route can work here, but it still work if you run it. So now let's do something now. This guy knows that if I'm sending a packet from PC1 to PC4, it's going to follow this route. Let's check our PC3 if it has an IP. Okay, go to this IP, no IP yet. Let's put IP here, 192.168.4. What we'll give it, .15 or so, .15. The computer will populate subnet mask. The fourth gateway is what? Our gateway is 192.168.4.1. And then that's it. For we to, okay, for we to confirm that, we go to this IP, this place, we ping our gateway files, ping 192.168.4.1. Can we reach it? Okay, we can reach our gateway. So we stop that one. So now, if you see that, let's send a packet across the board now from PC1 to PC3. Let's do simulation now. I would send it. I want to send a packet from PC1 to PC3. If you see it, it says successful, right?
Mm-hmm.
Router 0, because that's the name it gives it before. There's one successful. Because I pick, I send this guy PC1. Can you see how I pick it?
Mm.
I click on this PC. I can't carry the same packet. I click on this two PC. I'm saying both of them should send packets.
Yeah, I'm going.
Hello. So at this point, you can see that PC1 can send to PC3. But the question is, can PC3 send packet to PC1? Can it fly? Okay, let's try it. This is PC3. Send a packet to PC1. Okay. So no functional port on the packet. Okay. PC3 is sending a packet now. It doesn't even know where to send the packet to, because this router doesn't know anything about this place. It will fail. So that is that. So let's continue. And then see, we have some successful, we have some failed. The one that's successful is the one coming from PC1 to PC3 because there's a route for it. So how can we troubleshoot that? We can go to our router again, do end, and then do show IP route. See now, I was saying before that it shows X. Oh no. It was showing only C before, which is connected, but now it's showing S now. S means static. We have configured static route to this one, to this one. It shows that if you are going to .4, you follow this vi 2.2. If you are going to .3, you follow the same route. Before, it doesn't know anything about this connection, this subnet. But now, the firewall or the routers has learned that route, and then it has put it on the routing table. So if you are hearing about routing table, this is the routing table. So every time we look at this is where we troubleshoot. If you're having issue on your network, the first thing you check your routing table. It's no more than this. The only difference is when you're working in a large organization, the routing table will be more. And then to show your routing table, you can specify it. Like now, you can do show IP route, type, include line expression. Include what? Include, is it not? Oh, show route, include static, right? I don't know if it's gonna fly. Okay. It shows it remove all this one, just show only the static. And then why many people don't use packet tracer is it's limited to some configuration, but it's good to learn all this. When I have another lab, we can test some advanced configuration on it. But the important thing is that we get the logic behind the static route. We have configured this one. The same way we configured this one with these two commands, the same way we do it here, the same way we do the other one. So now I will copy it, and I paste it on my notepad. I will paste it here, paste. So I'll remove this one router. I'll remove this one. The only thing I'll need to change here, I'll just change the subnets. So I'll do config E, and I'll send this command to the two routers. So this one from the Texas router, we have it needs to know about .1 and .4. So I'll copy this one, copy, and I paste it on Texas router. Okay, it says invalid. Okay, it's invalid because I need to change I need to change this default, the gateways. So now on this side, the gateway will be .1. This one, the gateway will be what? 3.12. Is that clear?
Yes.
3.1. The gateway is where the router will follow to send the packet. So I'll copy it again. Okay. Even if you look at the error message, it said invalid next up address. Let me say end. So I will paste it here. So now the router will learn the route. I'll do route. So we have done do route, and then the router knows about this subnet now and this one. So the only one we need to configure now is South Carolina route. The same thing we need to do there. We go to our notepad. We just need to modify it. This one will be 3.2 because that is the only gateway it has. 3.2, and then we change the subnet. The router will be coming from its own domain. The router knows about .3 and .4, but it doesn't know about .2 and .1. So we just need to tell it about .2 and .1. So now we put 1 here, we put 2 here. It may seem confusing, but when you are doing it on your own, it will paint more clarity. Okay, this is South Carolina router. We paste it here too, and then we click enter, and then we do route. So at this point, if we send a packet from, if you ping from, let's do something first, ipconfig. Okay. Okay, even this one, there's no IP there already. Let me put the IP configuration. So IP configuration of this one will be 192.168.1.5. The subnet is 225, and then the gateway will be 192.168.1.1, because that's where the packet will be sent from this place to that place. So we have completed that one. So if I go to command prompt again and run that same command, ipconfig. So you see now, this is the IP address. So let's ping the other subnet, which is ping 192.168.4.15 or so. Okay, invalid command. Instead of ping, I write ping. Ping. Okay, 192.168.4.15. It's not pinging now. You see, it's not pinging. So why is not pinging? Let's check if this one has, maybe we are pinging the right IP. Okay, 4.15. 4.15. Okay. The mode that we can troubleshoot this is, number one, see the default gateway. See, say, which one am I able to click on? This one. Okay, let me check this default gateway for this. 4.1. Everything's okay there. So if you want to troubleshoot this, the first thing you need to do, first of all, you start pinging it one by one. You ping from this one. But see now, you see what happened? Hello?
Hello.
You see it's working now. It's drop a packet. Maybe, you know, when we pasted this one, it takes some time before all the routers will propagate and share the routing table. So when we send that command, the routers has not completed the propagation, but now it's flying now. If you send a command, where 15 now, see, it will work. It drop one packet and then send the 3 packet. Let me, okay, it's on simulation before. So let me do it on real time. So look at it. See, you can talk to 15, which is PC3. So now, if you carry a packet, we go to simulation, carry a packet from, let me play it. Carry a packet from PC1 and then drop it to PC3. They should be able to communicate. And you show successful, successful, successful. So this is what network engineer or network engineers do every day. What they make sure is, they make sure that there's a seamless connectivity between their users. There's nothing concern them about security. When I mention nothing concern them, is they are no more concerned about security. Is our job to talk about security. Now, this connectivity now, it has no security. We can do some layers of security by like doing some VLANs, like doing some ACL on the router, which is not a net generation, it's not certificated enough to block modern day attacks, which is the job of the firewall. But the network guys, they make sure that there's a connectivity between all the nodes, between all the devices. And then what we have done so far here now is just static routes. We do static routing. It's not difficult, very, very simple. What we do is we give information that the router is known about to it, period. So when next time we're talking about OSPF, BGP, you will now see they are the same thing. It's just being these different commands. It's this, to me, dynamic routing is good. Dynamic routing is good, but you must do something on the router. The same thing we do on the route, on this static, we do similar thing. Similar thing in which sense, we must let the dynamic routing configuration knows about those not connected. No, that one, if you're talking about OSPF, we only need to know only what you have. It will propagate its own routing table and send everything to the neighbor or to the neighbor router. That's one of the advantages. Like now, where we are bringing all the information that all the router doesn't know. In dynamic, they don't work like that. How they work is, I will share everything I know with you. You share everything you know with me. In other words, you know what I know what you know. That's how it works. You become my neighbor, I become your neighbor. That is the concept behind dynamic. But in the static, look at this Texas router. It doesn't tell the GA router about 192.168.3 information. But if it is dynamic, the Texas router will tell GA router about everything it has. The same thing, GA router will tell the Texas router everything he knows about .1 because Tesla know about .2 already. He doesn't care about .2 anymore, but he's care more about what he doesn't know, which is .1. So they will share their information across the board. They will now form adjacency. All of them will become neighbors. So when we're doing what's it call it? OSPF, we will do more, we expatiate more about that. But the theory behind all this are very simple, but the most important thing that can seal the information in our mind is to try it on our own. So you can copy this topology, try to configure it. It's better you even make mistake than not to try it at all. So this is where we call it a day. We have covered what is routing so far, and then what routing is, and then we've successfully configured all the interfaces, done the static route, and then test it. Everything's working. We can ping from PC1, from PC3. Oh, let's even try PC3 to PC1. So now ping 1.5, right? 1.5. Okay, it's in simulation mode. If in simulation mode, you'll be dropping a little bit. It'll be sluggish, I mean. So I remove it from simulation mode to, okay, let me even stop, let me stop recording. I will need to reduce this because it's too long. Stop.